Yesterday I posted a video that talked about the dive testing that we did and the associated post-flight inspection. Due to some of the details that I won't go into here, it's not my airplane fundamentally, we only talked about the brake and the issues we had with the brake. There's a little more to the story. I don't know if you can see it in this light, but there's a crack that runs down the spar of the horizontal tail. See the paint's lifting up. Alright, so when you find something like that, especially after a envelope expansion flight, it's easy to get really nervous, right? We know we were going really fast. We know that we did a stick wrap while we were there. To find something like that starts to point to things like overloaded structure, maybe associated with flutter, and you start, thinking about how maybe close you got to a really bad scenario. There's a lot of other things that happened also on that flight that are much less scary reasons why we could find that kind of damage. For instance, we were up really high. It was really cold. This is a California airplane. It was well below zero where we were. So tonight, I want to take some time to go through the process of understanding the structure around that crack, decide what the next path would be, but also take this opportunity to be honest with you guys about all of the stuff that goes on behind the scenes to make a test like this happen. Since yesterday we were looking at the crack, I've now mapped it out here with the Sharpie. So you can see it's actually pretty big. It ends up being about maybe 14 inches long, 12 inches long, something like that. If we tap test it, we just have just a split washer here, just something hard. You see we got a couple things going on here. This is the spar area here. So you can hear the spar there, and then this is the panel forward of it. So this is some sort of a big open area, right? And then, so the main spar is traveling through here, right? And we're forward of that is where this crack line forms. So the question is, are we dealing with something in the paint? Are we dealing with something where the skins may be pulling off, where the skins themselves are failed? So I'm going to hit the books. I'm going to get the plans out for the airplane and see what's going on in this. All right, so I've been going through the plans here, and I'm not finding a good drawing of the horizontal, which I guess isn't that surprising. But what we can see here is this is the rigging of the horizontal section, and this describes placing the horizontal. That's the horizontal. That's the vertical tail. Horizontal, vertical tail on the fuselage and jigging it in place. So yeah, it just describes how they want you to do that. All the way down to how to rig it to make sure it's straight and that it's at the right incidence. So I don't see anything about how to close it out or what they do for that. But I think what we're seeing right here is the aft spar that we're looking at, where the front of the crack is, we think, right there. And then we see that there's one rib on either side of the fuselage. And then if we look over here, just that same one rib, and then there's one mid rib, and then you can see the forward spar doesn't quite go all the way to the end there. So I don't know if you can see that very well. Yeah, so forward spar, and then the aft spar back there, and then outboard rib, inboard rib, and I would bet you anything that inboard rib is pretty darn close to the fuselage. So now what I'm going to do is just map out, using a tap test, map out where a structure is in the tail to try to figure out anything that we can about that crack. All right, so you can see with a lot of tap testing, I was able to identify the forward and aft spars as well as the two ribs. And the interesting thing here is that the crack is sort of away from everything. I don't actually have a picture of the top skin, but based on what I'm seeing, it looks like it's a just a joggle in the front with a single piece skin that goes from the trailing edge here at the elevator brake over the aft spar, over the forward spar, and then close out on the leading edge. So what I'm seeing is there's not like a lap joint here at the spar. There's not some sort of two C channels pushing together that could be peeling apart to give me this paint problem, which backs up my theory that it's probably not a Q related or flutter related, so not structure, the elevator beating itself, which I see it in the video. I didn't feel any vibration. I didn't feel any secondary oscillations after I did the stick wrap. So all that's left is it was either because it was really cold or because of the pressurization. So cold is pretty obvious. The carbon fiber probably expands and contracts with temperature at a different rate than the Bondo and the paint that's on top of it. So that can put some loads on the interlaminar stuff, the bonds between the two, and maybe it popped off. The other one, which I think is my favorite explanation, is that it's not uncommon for an airplane like this for consideration not to be made to vent all the bays. So as you go up in altitude, the atmospheric pressure goes down and these swell up like a balloon, and that can cause things to stretch and maybe that delam to happen. So as of right now, that's what I'm guessing. So one of the other things that happened today associated with this is it turns out that the rush we had to deliver the airplane before the end of the year, which is why we've been pushing so hard for the last couple of weeks, that has changed. The owner's schedule has changed. So we have a little bit more time. So it allows me to go in a little bit more depth about something like this with you guys, since the airplane's going to be around for a little bit longer.